So let's take a look at this bell ringer and see if we can figure out by applying what we do know. Let's apply what we do know out there and see if we can figure this thing out. So first of all, if I draw an axis, let's just draw an axis over here to kind of get an idea of what we're looking at. And let's draw another axis here. I'm trying to visualize what we're doing here. So let's look. So this is -3, 1, 2, 3. There's my -3. This point here is 4. 1, 2, 3, 4. Now, let's see if we can draw a triangle to represent that, because that's what we've been talking about. We've been talking about triangles. So if they had a circle, and it went out somewhere out here, we know that let's see here, at this point here would be what we're looking at, okay? So we're looking at this point, and we know this value is 3, and this value is 4, negative. And we have this circle going around here somewhere that we've been talking about, but we're not worrying about that right now. We're just looking at this triangle. Now, if you remember Pythagorean theorem, it tells us that x squared plus y squared, I think it's a squared plus b squared equals c squared. So a squared plus b squared is equal to c squared. Or we're going to turn that into x squared plus y squared is equal to the radius squared. Well, I know x is -3, and I know that y is 4. So when I think about this, well, 3 squared is 9, 4 squared is 16. Let me erase that right here. I wrote too quick. Let's go. So 9 plus 16 is equal to r squared. R squared is equal to 25. R is equal to 5. So we found the 5 here, which is what's known as the hypotenuse. So let's go back and look at our 6 things that we're dealing with. And let's say this is theta. I know that sine of theta is equal to, let's see, sine is opposite over hypotenuse. Opposite over hypotenuse. You've been saying just a 4, but remember that was a radius of 1. Now we can't just divide by 1, so now we have a 5 there. 4 divided by 5. Now let's look at cosine theta. Well, cosine theta, in fact, adjacent or hypotenuse, adjacent over, is -3 over 5. This means it's in quadrant 2. Quadrant 2, we're over here versus quadrant 1. We're in quadrant 2. So you're going to have x's negatives, y's are positive. Tan, let's see, well, tan of theta is equal to tan of theta, opposite over adjacent, opposite over adjacent. So that's 4 over -3. But for simplicity, we can just write that -4 over 3. We don't have to put the negative with either number. Now let's learn at the new ones we've learned at. The opposite of sine, the reciprocal of the sine of theta, is cosecant. Cosecant of theta. Because it's backwards, it drives us crazy. You hope sine would be secant, but no, it has to be cosecant. So the reciprocal of that, instead of 4 over 5, it's 5 over 4. It's 5 over 4. And the secant of theta, we go back and look at cosine. Well, cosine was a negative 3 over 5, so this becomes negative 5 over 3. And let's look at cotangent of theta. Cotangent of theta, well, that's the opposite of tan, so instead of the reciprocal of it, so instead of negative 4 over 3, it's negative 3 over 4. So that's what we're looking at. We're trying to figure these out. That's what we're looking at. So